चलिए दोस्तों शुरू करते हैं without wasting a time. In the last lab, we have seen that we have configured the IPFRR LFA, and in that lab, after doing the configuration and doing the verification, we have found that when we are checking the route for the P4, P4 loopback on the P2, we have seen that FR in the backup path were taking the suboptimal path. It were taking the this path as a backup path where the metric is the 220, 200, 10 and 10, 220. While this was not taking the path of this path 10, 20, 30 and 40. So the 40 and so it was selecting the suboptimal path. It was not taking the optimal path. In this lab, we will configure the Ti-LFA with the segment routing we have already configured, and we will re-verify the same thing from on the P2 router. We will re-verify the route for the P4 and we'll check what path as a backup path it will take. The main function of Ti-LFA is it will provide the 100% link protection in all failure type, and it will also avoid to use the suboptimal path as we have seen in the case of IPFR or LFA. And one more thing is it does not use the targeted LDP session. So let's jump to the configuration part. I will show you the configuration of iOS XR and iOS XE, how to enable the Ti-LFA. After that, I will finish the configuration on all of the boxes on all of the routers. And after that, we'll jump for the verification part. Let's go to the configuration part. This is our first node. Let's enable the Ti-LFA. Let me quickly show the first show run for the configuration available in the IFS. This is the process we have configured ISS core. This is the net ID and this is the segment routing label in the ISS, and this is the nodes prefix we have configured on the loopback for this router, and these are the interface, and this command we have configured in the case of IPFR LFA. So let me copy and paste the configuration. So basically only two commands are required to run the Ti-LFA. To run the Ti-LFA, to enable the Ti-LFA, these two commands require or the interface which we are calling in the ISIS process. Let me commit. So this is the config done for the P1. Let's jump to the iOS XE. So this is our second node and this is the iOS XE box. Let's see how we can enable the Ti-LFA on this router. Before that, let me quickly show the show run. So this is the segment routing configuration, global block and nodes in the prefix. We are doing it here. These are the interfaces which we have called in the ISS process. This is the ISS process we have, and this was the command we enabled in the last video for the IPFR LFA. Including this command, one more command is required to enable the Ti-LFA on IO XE box. These two commands are required. Fast route earlier was there, and this is the new command addition, fast reroute Ti-LFA level 2. So let me finish the configuration all of the boxes. After that, we'll do the verification. I've done the configuration of all of the node. Let's do the verification now. Now we on the P2 node. We'll check the route for the P4 node. Show IP route here 44.44.44/32, where we can see that this is the protected path and this is the backup path. Now it's taking the path where the metric is only 40. Earlier with the IPFRR, this was taking the path with metric 220. So it's avoiding the suboptimal path. It's taking the optimal path. This is the one function we can say in the case of Ti-LFA. Let's do some more verification here now. Show ISH fast route 32. We can see here the show chef IPv4 44.44/32. See that It's been posing on the backup path in the 400. So this is the node seed. Show as a fast route summary. We have an Anderson coverage here, and let's do one more thing. So we have another show as neighbor here. Let me increase the metric on the middle of the link which is connected from P2 to P1. P2 to P1. So this is the link. Let me increase metric. Show as code. Let's go to the interface. Address family IPv4, and let me put the metric here. 5. Same command here. If you see that now, let me quickly show you first the fastest route for this. So this is the fast route. This is the backup path it's showing. Correct. This is the P1, and this is the P node is selecting. There is the function, you can say P1 queue space. We'll discuss in another video how the P node is selected, how the Q node is selected with the PQ space. But as of now, we can see that it's first this will send the traffic to the P node, and it at the P node seed value 60300. After that, there is the final node destination seed value. So it will impose the two level. Like in the here we can see that in the Ceph, when we are on the Ceph command, the detail correct in the backup path we can see label imposed on the backup path two. First label with the first packet will go to the P node, then will go to the final destination 6 node. On the primary node, it's only imposing the empty set because this node is directly connected only. In the backup path, there are two label in the place.